The last part of this chapter is about phase shifter. If you want to add a shifter, if you want to add phase shift, sometimes you need to add a phase shift. We have a lot of applications that requires phase shifters. The simplest phase shifter is RC or RL circuit, like this one here. When you have RC or RL circuit, okay, and it introduces phase shift if you have an input voltage here and you take the output across the resistor, or you take the output across the capacitor. So this is the input, this is the output, or this is the input, this is the output. Okay, in this case, because of the capacitor, there will be a phase shift. And if you take the output across the resistor, the output is leading the input. So it is, you see, it's happened before. So the maximum happened before the input, like this. Okay. So if you have the resistor, the output across the resistor is leading. If you have the output across the capacitor, it is lagging. It is lagging. And the idea is so simple here that you just need to calculate the output over the input and check the phases. For example, if VO is A sine omega t plus theta, for example, and theta 30, then this is what this? Yeah, here it is. Okay, yeah. If you want to calculate the difference between VO with respect to VI, it is R divided by R plus J omega C. And J omega C here you have a R, and J omega C has a phase, has a certain phase, and J and omega C for the capacitor it is negative. You have negative sign here, so you have some negative sign. Okay, theta. So here when you move this to the numerator, will be positive. Okay, so theta here will be 30 degree, for example. This is just an example. So if you have an V out like this, and Vn is just sine omega t, for example, A or B, whatever, sine omega t. The output is A sine omega t plus 30. So in this case, you have a leading angle 30 degree. If you want to do the opposite, you can just take the output across the capacitor as we have here. So the idea here is that you just need to calculate theta. If you want to have a leading angle, use this circuit. If you want to have lagging, use this circuit. It's very simple. And theta is just tan minus 1 xc divided by r. Xc divided by r. Let us take a simple example on this one here. If, say, for example, design a 20 degree leading phase shifter. Okay, so in this case, we will take this circuit here. This is for leading. We'll take the output across the resistor. So this is the input and this is the output. And if it is 20 degree, then theta equal 20 degree. So theta 20 degree equal tan minus 1 xc divided by r. Here it is. 20 degree equal tan minus 1 xc divided by r. Then xc divided by r equal what? Equal tan 20 degree. Why? Because you just need to take this, move this to the other side. Tan minus 1 this equal 20. Then xc divided by r equal tan 20. Tan 20, here it is. If you take tan 20, 20, and then you hit tan equal 0.364. So this is the ratio between xc and r. So now, what is the question? Say select the values for x, for r, and c. And omega is 5. Omega is 5. So you can select any values as you like. Assume that xc is r is 1, for example, like what I selected the easiest number, r is 1. Then xc in this case is 0.364. That's it. Okay, and I know that xc is 1 over omega c. This is the amplitude. I'm not talking about j here. I'm talking about the absolute value. The amplitude is 1 over omega c. And the omega is 5. Then you can calculate c very easily here. You can say, okay, this is 0.364 equal 1 over 5. Yeah, here it is. Okay, so you just need 0.364 equal 1 over 5 times c. So you move c to this side and you move this to the other side here. So C equal what? Equal 1 over 5 times 0.364. So it will be 0.549 farad. That's it. That's it. So I believe this is a last example in this chapter. This is the assignment. All the problems in the assignment are solved in these videos. You will not find the solution in the videos that are on Canvas. So if you want to find the solution, check the solutions, you have to watch the videos. And I will mention this in the live lecture.